All right, I'm going to assume that you can see that there in the room. Good morning, and thank you for this opportunity to share with you some updates from JETT5. I'm Lauren Edgar, I'm at the USGS, and I'm sharing this on behalf of the JETT5 science team. JETT stands for the Joint EVA and Human Surface Mobility Test Team. And so this is the fifth in a series of tests that are aimed at analog activities to support Artemis lunar exploration. In terms of an overview of the test, this is the highest fidelity Artemis 3 EVA mission simulation that we've been able to conduct to date. It occurred in May of this year, so we are just now processing all of the great data that we acquired and figuring out the lessons learned from this test. But it consisted of 2 astronauts in the field in Flagstaff. We had astronauts Kate Rubins and Andre Douglas, and they were supported by a flight control team, including an integrated science team in Houston. Throughout the test, we conducted 4 EVAs to test science operations, the software, including some of the stuff Ben was just showing you, communication, navigation, different lighting configurations, the tools and sample management that would be required, looking at human factors, payloads, and hardware that are expected for lunar exploration. I'll also note that in this test, we had operations including 2 daily operational shifts. So we had an execute shift occurring during EVAs and a planning shift occurring between EVAs to evaluate what we accomplished to try and implement all of our science objectives. So the science team, this is a test that involved the full science team in both the mission preparation and execution. We had most of our science team gathered in the Mission Control Center in Houston, conducting real-time science support, integration with the EVA flight control team, and implementing our science objectives through that pre-mission work and real-time operations. And then we also had several members of our science team in the field that were providing some additional in-field training, EVA shadowing, and local expertise and providing that science ground truth. And when I say integration with the flight control team, I'll draw your attention to the diagram in the lower right. So where science comes into this flight control structure is that lower green box called the SIR, the Science Evaluation Room, is where a lot of the scientists will be supporting different positions. And then that gets funneled through the science officer to get integrated with the rest of the flight control team. So then the science officer is working with tasks and systems and relaying information and decisions from that SIR up through the EVA FICR position, flight director, ground IV, and eventually to the crew. So the science team for JETT5 is shown here. The science lead was Kelsey Young from NASA Goddard, and then Cherie Ackley's and I also served as science officers. The personnel that are listed here is comprised of both the competed NASA SMD science team and then also other NASA folks who were able to help with this test because we had a lot of different positions to try and staff here. Also want to note this is only a portion of the team. We had over 100 people involved in this, people from the flight ops directorate, software folks, the crew office. So really big test and really grateful for all of the support that people provided. In terms of the SMD portion of this, which is what we'll be focusing on in this talk, some of the test objectives were focused on refining the process for identifying and implementing science priorities across multiple landing sites, so carrying more than one for the first time. Further developing the roles and responsibilities of the science evaluation room and the science officer position. We're also trying to identify the workflow for the first time, figuring out what this planning shift would be, which occurs in between EVAs in response to what occurred on the prior EVA. Validating the physical requirements for the SIR room, assessing mass and sample management considerations, thinking about the images that were acquired by crew and how we're handling those as they come down in real time, and maturing SIR products and tracking tools. We're also providing feedback on the science and tool concept of operations. So the workflow that we followed for JETT5 is what we expect for Artemis 3, starting with exploration area orientation and discussion, which then leads to our detailed geologic mapping shown there in the middle. That geologic mapping then produces additional scientific questions and how those map to our science traceability matrix. Then we use that to identify different points of interest within the exploration area that we can help to identify and answer some of those questions. Ultimately, those get elevated to stations, and then we work those stations into a traverse, trying to hit as many high priority objectives as we can, given the constraints of the EVA. And then ultimately, the traverses lead to the procedures and ops products that we deliver to the crew. So what the crew has access to is a cuff checklist on their wrist, and that has some of the procedures and ways of conveying different science priorities, any, detailed maps or things that might help guide particular procedures that we're asking them to conduct. We have a more detailed map book, which has all of the traverses and ways that we can display geologic units and terrain, also conveying science priorities and testing out the best ways to do that in this test. And then an execute package that's sent daily in response to what occurred on the previous EVA, questions or tips for the crew, things that we want them to focus on, and anything that we needed to replan in response to what has occurred so far. So for JETT5, the landing sites were in the San Francisco Volcanic Field in northern Arizona. This is about 45 minutes north of Flagstaff. And for those of you familiar with the area, you'll recognize SP Crater and SP Flow. For reference, I also have the JETT3 test, which occurred in October of 2022, shown there in purple. And then this time, the red circles correspond to the JETT5 field locations. So you can see we were considering both a primary landing site off to the left and a secondary landing site off to the right. And for reference, each of these is that 2-kilometer radius that we expect for early Artemis missions. And so these are 4 kilometers in diameter for the exploration area. We found out right before the test that we were going to the prime landing site, but all those different operations products that we showed you and the process that we followed for more than one site. So that was really helpful to figure out how to do that as a science team. Here's a look at one of the documents from the map book and then a station inset map. And so we're testing various ways of conveying the geologic units, where to look for possible outcrop, shown in this kind of stipple pattern, and how to convey priorities and places that we would suggest the crew go and explore. In terms of the EVA overview, we did complete 4 EVAs that completely or partially addressed most of our science objectives, and those objectives were tied to surface processes, volcanism, volatiles, and age relationships. You can see on the right here, this is the EVAs as executed, the path the crew actually followed, excuse me. And so, yeah, you can see that we still, were able to accomplish most of the EVAs that we had planned. One of them got cut a little bit short, but still made it to the majority of the sites that we had intended to go to. So the test is executed. We also had different EVA conditions for each of the different EVAs, so we could test out different objectives, including things tied to different lighting conditions. So some of the EVAs were occurring during the day, some of them were at night. The crew is testing out different suit configurations. Here we have the XCon suit, which is a more realistic approximation for some of the mobility constraints that we would expect, versus the backpacks, which give you more mobility but maybe less realistic. We had the crew in and out of communication, in and out of having a real-time video feed coming back to Houston and testing out real-time image return. A couple more photos of JETT5 as executed. So the crew was conducting geologic exploration and sampling procedures, testing out different lighting and working in simulated PSRs. We practiced a payload deploy. We had sample and tool management that we were focusing on, and of course, assessing the crew required photos. Meanwhile, on the Houston side of things, we were looking at SIR roles and responsibilities, validating the physical requirements for the SIR room. This is not the actual room, but we set up the room to approximate what it would be like so we can figure out what the key functions would be. Working on communication, data, and decision flow within the SIR, as well as science integration within the broader flight control team, shown from the science officer console here. We're also figuring out localization, both the analog side of things and the more updated digital localization updates, some of the great software tools Ben was just showing. We are also focusing on sample tracking and real-time image requests and interpretation, and tracking crew actions and evolving science interpretations, and how we can, quickly annotate and assess what the crew has acquired so that we can feed forward further directions.
1 minute.
Thank you. Last 2 slides here just show the planning shift. It was exciting to have planning shift for the first time, evaluating how to achieve our remaining science objectives in response to what happened, testing the handover between execute and planning shifts, shown in the upper right, there, upper left there. We also had a replanning day between the first set of EVAs 1 and 2, and then EVAs 3 and 4 at the end of the week, and how we might be able to best address that in the future, as well as the importance of our EVA field team providing that shadowing and that science ground truth. So the last slide here is just the summary that this helped to refine the workflow that Artemis science teams will use to implement our science objectives. first test to involve a planning shift, evaluating multiple landing sites and real-time image return. And we've generated a lot of science findings and recommendations. So stay tuned for that JETT5 final science report, because we still have a lot to learn and test, but it's really exciting to see the direct impact that these tests are having on near-term Artemis exploration. So I want to say thank you to the broader JETT5 team, both field and Houston, and to acknowledge that this work was supported by NASA's analog activities to support Artemis lunar operations. And if you're interested, the next call for participation will come out in December. So thank you.